Good day everyone, my name is Sam and in today's video I'm gonna talk about Texel Density. I'll go over what it is and how you can actually keep it consistent throughout a scene or a game. This video is gonna be in two parts. The first one's gonna be the PowerPoint slide in which I'm gonna go over the more technical stuff, and the second part is gonna be in the 3D modeling program. In my case, I'm gonna use 3ds Max, but everything that I say here can pretty much be applied to any program whatsoever, so you don't need to worry about that. I'm gonna try to keep this video short and sweet, but I'm gonna go over and guess it's gonna be 20 minutes long. So we'll see. Let's get started. So, definition and raw information. So we can't speak about texels without speaking about pixels. So texels is short for texture element, which is the smallest unit that makes up a texture. And pixel, in the other hand, is the smallest unit that makes up a screen. Even though both are related, they are not the same. So you can see it as follow. Pixel determine an image resolution, texel determine a mesh resolution. And just like with image, the more texel you have on a mesh, the more detail you will have, thus better quality. So where do you draw the border between the two of them? So let's say you download or create your texture image. When you are creating or downloading it, it is represented by pixels, but as soon as you apply that texture to a 3D model, it is represented by texels. So I'm gonna ask myself a question, because I think it's gonna be easier to understand that way. So if my image resolution is 1024 pixel and I apply that image as a texture to my 3D model, does it mean my mesh resolution is gonna be a 1024 pixel? And if so, does it mean it's useless to apply a 4K image to my 3D model if my monitor is only 1080p capable? First point, no. Mesh resolution is determined by texel density. Actually, the term mesh resolution is incorrect. The real term for that is texel density. So from now on, I'm going to refer to mesh resolution as texel density. Texel density is an amount of texel in a given amount of units. So I could have said actually in meter or in centimeters, but I just never saw someone use inch or feet to describe texel density. But I mean, it's possible. There's a little formula for that. It's texture size divided by given units equals texel density. So let's say I want to use a 1K image on every meters. Well, it's going to be 1024 divided by 1 meter. It's going to give us 1024 pixels per meter. But why is that? Because image resolution is expressed with two values. So a 1K image is 1024 multiplied by 1024. But why do we express texel density in meters or centimeters? Well, the main reason for that is for the consistency of texture quality throughout a scene or a game. So example, if I use a 10.24 pixel per centimeters in my game, my 1 meter brick wall will show bricks that are the same size as my 4x3 meter brick wall, because the amount of texel per centimeters is the same. So it's really more important the more you are working on a project. That way you don't have to go back and forth with your co-workers, because you're all going to be creating assets that follow this standard. So it doesn't matter how big you make them or how small you make them, because they would have the same amount of pixels per centimeters. Here's a little example showcasing what I just said. As you can see over there, you have three different models that follow three different TD. Texel density, and down there you can see 3 models that follow the exact same Texel density ratio. So as you can see, the bricks are not the same size across the 3 different walls, but in that case over there it is. So you can see it's way more consistent that way. Which bring me to my second point, and the answer to that is no, again, because like I mentioned before, I think it was in the first slide, pixels are different than pixels, meaning that logic is not true. So using a 4K texture on a mesh will actually greatly increase the quality. It is 100% noticeable on a 1080p monitor, but I mean you're gonna get more detail with a 4K, but it's not gonna be day and night. So you can see down below is a screenshot that I took of a video. I suggest watching it. I'm gonna link it in the description below. It's about a minute long, but basically this is the same screen resolution, but the dragon on the left uses an 8K texture and the dragon on the right uses a 4K texture. And you can clearly see in the head area the amount of detail on the left is really greater than the amount of detail on the right. And you can actually some squares over there which are pixels, and you look on the left and you can see that it's really more crisp and you don't see any jagged edge like in the right side. So yeah, texture size doesn't depend on screen size. Okay, now that we know what texel density is, how do you actually go on and apply that to your model? Well, first, UVs of a mesh is the main factor on how texels are going to spread across your mesh, and followed by that is the texture size. So you can have two scenarios when you're creating a new mesh. First, you have a tiling texture. So in example, the brick wall that I showed you earlier, or you can have a non-tiling texture. Now this is anything like any props whatsoever, a gun, a banana, anything that you can't really tile the texture across the mesh. And based on those scenarios, you're gonna have different methods to obtain the right texel density. As you can see right there how changing the UVs affect the texel density, and upgrading the texture size increase the texel density. Okay, so the first scenario, you have a tiling texture. In my opinion, this is the easiest one to deal with, because you can either choose to input the tiling value directly in the texture, or you can choose to scale the UVs up. So the first method, tiling value, if you want to keep the UVs within the 0 to 1 texture space, you will need this little formula to determine the right tiling value to obtain the right texel density. So it goes like this. You just add up the sum of the dimension of your mesh. So if I take, for example, my brick wall early on, it's gonna be 3 meters wide by 2 meters high by 1 meter depth, which is gonna be 6, multiplied by the texel density that I wanted to achieve, which is 1024 pixels per meter, and you divide the sum of that by the texture that you are going to be tiling across the brick wall, which is 1048 pixels, and this gave me a tiling value of 3, and I just input that in both the tiling, in both the U and V tiling value. There you go. The second method is going to be scaling the UVs up. This one's going to be done with free tools that I'm going to link in the description below. This is literally the press of a button, so you just press it and it's going to scale the UVs to the desired texel density. The downside to that is that you will end up with UVs that are outside the 0 to 1 texture space. So this might give you issues depending on the situation, but basically you won't be able to bake texture information on the mesh, and you won't be able, well, you will be able to paint on it, but I think it kills the whole point of painting, which is making a more unique mesh. But you won't be able to do that because it's gonna repeat the painting all across the texture. And the last point, now this one I'm not sure if I should have left that or not, but I know that most game engine now can generate a light map for you, so you don't need to actually worry about that. But I suggest doing some research depending on the game engine that you use if you want to bake lighting later on. Okay, so the second scenario is going to be when you have a non-tiling texture. Now, this one, in my opinion, is the most tedious one, but in this case, you have three options. First, you increase the image size. It's really simple, but it requires some thinking because you will often find yourself in a position where 2K is not enough or 4K is too much, but that's really effective. Second method is going to be adding another material. This one is simple as well, but I don't recommend using that on every model because the more material you have on a model or a scene or a game, the less performance you will get. So if you're making a render, it's going to increase the render time, and if you're making a game, it's going to decrease the performance of your game. So you want to use that technique on really important mesh. And the third method is going to be to mirror parts of your model. Now this one is, I don't know, there's not really a scenario that I can say. There's not a clear rule on when you should use it, but when you feel like it don't really matter that both sides are going to be repeating itself, well, you can just mirror them and it's going to be fine. And you can see that there, that by mirroring half of this mesh right there, I'm pretty sure I'm close to doubling the actual texture size, so you get a lot more texels when you mirror parts of your model. Okay, now that we have all the information that we need, how do we go on about setting a texel density? This is really up to the person or director creating the game or scene, and it is most likely going to be determined by the type of game and the interaction the player will have with the mesh. So there's a little table, and I'm giving full credit of those values to that guy over there, and I'm gonna link his article, which I took a lot of information from. So I suggest if you want to know more about how to go on about that, I suggest going read his article. But basically, this is the rudimentary value. You start with those, and you can just adjust them based on your needs. So this is pretty simple. The playable section mean that it's gonna be the mesh that are most likely going to be in interaction a lot with the player. The background is gonna be stuff that are spread not necessarily to be in relation with the player, but are going to be a good part of your scene. And the far object are really going to be like a mountain or something the player won't really get really close to it. And there are some exceptions to that. It's gonna be like stuff that will get much closer to the player than the usual. So in the FPS game, when you're aiming down this side, well, the holographic side is gonna get really close to the player, so you might want to give more texel density to that holographic side. The character is a good one. The face most of the time receive a different material because they need more detail. But basically, yes, I really suggest that you go see his article. He goes in more depth about how do you go about that. So the tool that you will need, everything's going to be in the description. So you will need text tool and polygon tool. Both of them are free. The full version are free as well. And this is pretty much every article source, and I'm giving credit to all those guys because they helped me make this video. So I will see you in 3ds Max. Okay, so here I am in 3ds Max. If you want to follow alongside, make sure you download those little plugin, which is Polygon and Text Tool, and make sure the units are set in centimeters. Okay, so I have a pretty basic scene, but I'm going to be able to explain clearly how to use the different method to get the right texel density. So let's say I want to keep a 1024 pixel per meter texel density. This is the texel density I want to achieve throughout all my assets. So I'm gonna start with the hardest one. This one is, let's say it's a props. It's a non-tileable texture, and I want to keep the UVs within the 0 to 1 texture space. Okay, so the first thing we want to know is what's the current texel density. So I'm just going to apply a checker to that. And if we just go over there, click the face, and under that option right there you can set the different map resolution. Let's say I want to start with 1K. I want to see if with 1K I can achieve the texel density. So I'll just press that and get texel. As we can see right there, it's currently sitting at 250 pixels per meter, which is way far off. So let's see if I crank the image resolution. Still not enough. Let's see with 4K if it works. Still not enough. So from now on, there's a few things we can do. Now, if you remember the slide, the first thing was to increase the image size. So that's what we just did. But as we can see, by just increasing the image size, it's not gonna work. So based on that, I could take the interior and assign a different material to that. Or I could try to mirror a part of my model so that I can get more texture space. I'm gonna go with the second technique because I think it's more suitable for this particular model. So I'm just gonna mirror pretty much the whole model. So let's just delete this other section right there, and before applying a different material, mirroring the model, you want to make sure that you actually pack it before you do it. So I'm just gonna pack it, gonna lower that. So collapse, mirror, copy, another collapse. Make sure you remove the doubles. Just like that. Okay, so now I just mirrored the old model. So if you take a look at that, what it did is it actually take the other half and just overlaps the UV island with the other half. So if I just go by element, take it, as you can see they are overlapping perfectly. So that way they share the same texture space. So effectively you are saving up 50% texture space. So if now I try to calculate texel density and see where it's at. Okay, this is currently too much, so let's see if I drop down the image resolution to 2K instead. Not enough. Okay, so there's a few things we can do now. Since we want to keep the UVs within the 0 to 1 texture space, we can't scale them up more because they already fit pretty much the whole space. So I'm gonna go with a higher texture resolution, and instead I'm going to use text tool, and I'm gonna use those little options that allow you to calculate automatically the texel density that you want. So I'm using a 4K image. I want to have 1024 pixels per 100 centimeters. And so you just, oh, forgot something. So you just go ahead and take all your UV island. Now everything is set properly, and you just right click on get set. Now it calculated for us the right texel density. So if we take a look at our current UVs, you can see that they got scaled down a lot. So if we take a look at the texel density, as you can see, it's sitting right where we want it, 1024 pixels per meter. So this is basically how you do it, how you deal with it. You just start by increasing the image size, see if it fits or not, and after you reach the point in which it doesn't, whether it's too much or not enough, you just go ahead and play with the UVs to get the right texel density. So that's pretty much it. Second scenario is going to be a tileable texture, but we want to keep the UVs within the 0 to 1 texture space. For this one, I'm going to use an image texture because it's going to be easier to scale than those checker map. So, oh yeah. Oops. So I'm just drag and dropping the image into my material tab, and I'm going to assign a 1K image to my 3D model, just like that. Okay, so we want to know, like with the other one, where it's currently sitting at. So I'm using a 1K image, get texels. As you can see, I'm sitting at 164 pixels per meter, which is not enough. And if we remember the formula for the tiling value, this is the sum of the dimension of the mesh multiplied by the texel density per meter that you want to achieve, divided by the texture size that you are using right now. So you have a little option right there that you can click, and it's going to give you the dimension of the mesh. And if we take a look at that, it's going to be 6 meters in total. And you multiply that by 1024 pixels per meter, because this is the texel density that I want to achieve, and you divide that by 1024 pixels because this is the size of the texture I'm using. So this will end up being 6. So if I just bring that up right there, I just go to my texture panel, uncheck that, and just input 6, 6. So now if we take a look at that, it now became way more appropriate. But if I'm correct, okay. If I'm correct, it's not going to be able to calculate the texel density because it doesn't calculate the tiling of a texture. No, it's currently sitting at the same. So a good way to know if your model actually have the right texel density, this is actually a good practice that you should implement when you're working on a model, is you just make a reference texel density plane. So I'll just make a 1 meter by 1 meter, just like that. And you basically apply, well, you can apply any texture whatsoever, but I'm gonna apply this same one. I'm just working on the material tab. Okay, I'm gonna change the UV. Uncheck that. Collapse to available point. Okay, so you just, well, basically this if we take the formula, the first one I gave you about how to calculate texel density, it's the texture size divided by the units equals texel density. So I'm using a 1K texture, 1024 divided by 1 meter, which is going to give us 1024 pixel per meter. So this is actually right off the bat the correct texel density. And if we want to make sure about that, we can just click on that and it's gonna say 1024 pixel per meter. So we can use that as a reference and just pretty much compare both of them. So if we take a look at those, it's the same size. So we know that the tiling value that we input into that texture actually are correct, and they are going to give us the right texel density. And the last scenario, it's going to be this one. Now this is going to be really easy. I have a tiling texture and I don't mind scaling the UVs, so you can just, I'm gonna assign a different, let's see, I'm gonna assign this one instead. I want to know what's the current texel density. Get texel, 92, not enough, so you just pretty much take everything and just input the image size that you are going to use. In my case, I'm using a 1K image. You input the texel density that you want to have, 1024 pixel per 100 centimeters or meters, and you right click. And there you go. This is pretty much how you do to keep a consistent texel density ratio. And this is pretty much it. Now if we take a look at the UVs, it's gonna be really big and messed up. You can pack them like that, but as you can see, it's outside the 0 to 1 texture space, but we have the exact same texel density that we want. Now if we take a look at, let's say we want to make sure it is, just select one, get texel, there you go. So now when you bring all those models in your game engine or whatever, it's gonna be really consistent and you won't see any gap in quality difference. So yeah.
Allow me to introduce myself.
Hey guys, thank you for watching. Make sure to subscribe if you want to learn more about 3D. Let me know in the comment section what topic you would like me to cover, and I'll make sure to add it to my list. Peace!